In lesson 2.2, we reviewed graphing lines, and now we're going to review writing equations of lines. So first thing, we have our slope-intercept form of a line. We know that's y equals mx plus b. It's also, we can call this function form. And so this says write the equation of a line with a slope of 2/3 and a y-intercept of 0, 7. Well, y-intercept of 0, 7 just means it crosses the y-axis at 7. So this one's really straightforward. We have y equals m, and m is our slope, so 2/3, times x plus the y-intercept, which is 7. That's our answer. Here we have another form for the equation of a line. It's point-slope form. This is helpful when you have some other information besides just the y-intercept and the slope. So we'll be using this throughout the rest of this lesson, this point-slope form. So you need to commit this to memory. This is y minus y sub 1 equals m times x minus x sub 1, where x sub 1 and y sub 1 is just a point on the line, and m still represents the slope. So we do need to remember our equation for slope. Slope is y sub 1 minus y sub 2 over x sub 1 minus x sub 2. And so we'll need that as we work through this lesson. Write the equation of a line that has a slope of -4/5 and passes through the point 1, 4. Express your answer in slope-intercept form. Well, what we're going to do is we're going to take the slope, point-slope form. Y minus y sub 1 equals m times x minus x sub 1. Now, it asks us to put our answer in slope-intercept form, but what we do is we use this point-slope form first, and then once we have plugged everything in, we change it to slope-intercept form. So we have a slope of -4/5. That's our value for m here. And then we have y minus y sub 1. Well, that's the y value of our point, so y minus 4. Make sure you have your signs correct. And then x minus x sub 1, well, that's our point here, which is 1. So this technically is the equation of the line, but it asks us to put it in slope-intercept form. So we will distribute the -4/5. So we have -4/5 x. Negative times a negative is positive, so plus 4/5. And then we'll go ahead and add 4 to both sides, which will give us the equation of our line. So y equals -4/5 x plus 4 4/5. And that's the equation of the line in slope-intercept form. So now it's nice and easy to graph if we had to. Next one. So as we go through these, they're going to be progressively more difficult, which they're not hard, they just have a little bit extra work that we have to do. So write the equation of a line that passes through these 2 points, -4, 3, and 2, 6. Express your answer in standard form. So we are going to put it in ax plus by equals c form, which we don't start with that. We're actually going to start with point-slope form. Point-slope form, y minus y sub 1 equals m times x minus x sub 1. Well, we have 2 points here, so we actually can use either point for the point we're referring to, but we don't have the slope. So what we need to do first is we need to find the slope of this line. And so, as I mentioned in the last slide, that's y sub 1 minus y sub 2 over x sub 1 minus x sub 2. And so in this specific case, we can do 3 minus 6 over -4 minus 2. This gives us -3 over -6, which reduces to positive 1/2. So now we know our slope, and we know a point. Now I use this as my y sub 1, y sub 2, but it actually doesn't matter which point you use. It will still work out. You'll have the same standard form. So let's go ahead and use this, just this first point here is fine. So we have y minus y sub 1, so minus 3, equals m, which we just found the slope, x minus negative 4. So we want this in standard form, so that means we want the x and y on one side and the constant on the other. I don't think I mentioned it before, but when we have standard form, we prefer not to have fractions. So this right here is a plus. So we have 1/2 times 4 is 2. And so what I'm going to do is I'm going to subtract negative 1/2 from both sides, 1/2 x, sorry. That gets the x and y on the left side, and then I'll go ahead and add 3 to both sides. And we get negative 1/2 x plus y equals 5. Now this is not the best form because, as I just mentioned, we don't want fractions, and actually we usually like to have the x term be positive. So in order to get rid of fractions, we multiply by the least common denominator, which is 2. In this case, I'm going to multiply by negative, both sides by negative 2, so that x value will be positive. So multiply both sides by negative 2, and then we'll get our answer. We distribute this, which gives us x minus 2y equals negative 10. So again, the reason we multiplied by that negative 2 is because we prefer not to have fractions, and we prefer for x to be positive. And so that is our answer. You could always check this by plugging in these values to see if they work. You don't have to, but let's just real quick think through this. If you put negative 4 in here for x, minus 2 times our y value, which is 3, that does equal negative 10, because 4 minus 6 is negative 10. Same thing with these. You could plug those in. We'll now look at parallel and perpendicular lines, and we want to learn a couple things here about them. How do slopes of parallel lines compare? Well, parallel lines have the same steepness, so therefore their slopes are the same. So slopes are equal. This is a really important concept to know. If we know the slope of a line, we also know the slope of any line parallel to it. Now we want to check out these perpendicular lines. It's not quite as simple, but we'll be able to figure it out looking at this example. So let's find the slope of this line. We can do rise over run. So this is rising 1, 2, 3, 4, 5, 6. And a run of 1, 2. So that ends up equaling 3. So we went from this point to this point. Now let's do the slope of this other line. We'll do this one in red. This let's start in here, we go down 1. So down 1 and right 1, 2, 3, right 3. And so we look at these two slopes, and what do we notice about them? Well, they are negative reciprocals. And that is true about slopes of parallel lines. Their slopes will be negative reciprocals of each other. So if I have the slope of a line, I take the opposite, I change the sign, and then do the reciprocal. So make that negative, negative 3, reciprocal of negative 3 is negative 1/3. So here's an example for us where we use this. Write the equation of a line perpendicular to, got a little too many y's in here, y equals 3/4 x plus 7 that passes through the point 6, 2. Well, from this, the information that we get from this, the lines are perpendicular. This slope is 3/4, so the slope of the line that we want is going to be the negative reciprocal. So we want to change the sign and do the reciprocal. So the slope that we want is negative 4/3, and now we have the slope and a point, and we can go ahead and do point slope form again. Y minus y sub 1 equals m times x minus x sub 1. Know this formula. So we have y minus 2 equals m which is negative 4/3. We knew that because of negative reciprocal, x minus 6. And then we'll simplify this. It doesn't tell us what form to put it in, but usually if nothing's mentioned, the preferred form is slope-intercept form. So we can distribute. So we have negative 4/3 x and multiply this, so this is plus 24/3. I'm having trouble with writing my 4s. Oh, this reduces to 8. So we can add 2 to both sides, and then I'll go ahead and put my answer over to the right here. So y equals negative 4/3 x, and then 8 plus 2 is 10, so plus 10. And there's the equation of a line that is perpendicular to this line and passes through this point. And quick summary, equation to find the slope of a line. So slope, we can think of 2 different ways. We can think rise over run, that's if we have the graph already, or if we have a couple points, we know y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Slope-intercept form, y equals mx plus b. M is the slope, b is the y-intercept. Point slope form, we use that several times, y minus y sub 1 equals m, which is the slope, x minus x sub 1. We don't usually leave things in this form. That's usually to help us get our answer, and then we change either to slope-intercept or to standard form, which I know is not up here, but now it is ax plus by equals c. We don't usually want fractions, and we'd rather this be positive. Slopes of parallel lines, well, they're equal. Slopes of perpendicular lines, negative reciprocal. And that's the things we need to graph or write the equations of lines.